This question belongs to the subject Digital Logic Design and was asked in GATE 1991. So it has three parts. Let us see all the parts one by one. So part A is analyze the circuit in the figure given below and complete the following table. So here we have been given a figure which is a circuit and we need to complete this table. So here what we will do, we will find the value of this Qn. So Qn. So this basically are AND gates and this is an OR gate. This is an OR gate and this is an AND gate. So what is the input for the first AND gate? So it's basically OR of three terms. So first term is an AND gate. What is its inputs? Its input is the previous input Qn minus 1 and with the A plus this one which is A into B plus this one which is B into the previous input B into Qn minus 1. Now we need to fill this table. So when A and B are 0, what is the value of Qn? When A and B are 0, this becomes 0, this becomes 0 and this becomes 0. So the whole terms become 0. Okay. Now the next thing is when A is 0 and B is 1. When A is 0, this becomes 0, this becomes 0 and B is 1. So this becomes 1. So we get Qn equals to Qn minus 1. Qn minus 1. Now when A is 1 and B is 0, if B is 0, this term becomes 0 and this term becomes 0. And A is 1, which means this term becomes 1. So Qn equals to Qn minus 1. When both are 1, then we have this term as well as this term as well as this term. So A is 1, so 1 into something is that only Qn plus 1 plus 1 into 1 is 1 plus 1 into anything is that term only. Qn equals to 1 plus anything. 1 plus anything is always 1. So 1 plus anything is always 1. So we get answer to be 1. The answer is 0, 1, Qn minus 1 and Qn minus 1. Now let us see option B. So option B states find the, let me first clear this out. Option B states that find the minimum sum of products form of the logic function f abcd equals to sigma m 0 to 8 10 15 plus sigma d 3 10 3 11 12 14, where m and d represent the minterm, m is the midterm and d is the don't care terms. So first of all, here there are 4 variables. So let me draw the 4 variable K-map for you guys. So 4 variable K-map looks something like this. It's for minterms. Okay, here we have AB, here we have CD. It's 0 0 0 1 1 1 1 0. It's 0 0 0 1 1 1 1 0. And let me write the indices over here. 0 0 0 0, it's 0. 0 0 0 1, it's 1. 0 0 1 1, it's 3. 0 0 1 0, it's 2. This is 4 5 6 7. This is 8 9 10 11 12 13 14 as well as 15. Now let me fill this. Here we have minterms in 0 2 8 10 15. So 0 2 8 10 15, and we have don't care terms in 3 11 12 14. So 3 11, then we have in 12, and then we have 1 in 14. Okay, so now let us do the grouping. So how can the grouping be done? Here we can have these 4 can be grouped into 1. Okay, yeah. And how can be the second grouping? For the second grouping, we can group either these two together, but then this won't come. Okay, for the second grouping, we can group this one together. So what will be the output? So the output for this 4 corner groupings would be this and this, which means this is 0 and this is 1, which means C will get cancelled and we will get D complement. Okay, for this and this, the different things, which is A will get cancelled, we will get B complement. Okay, for this term, let us see. This is 1, this is 1, this will remain, 1 0 will get cancelled, so we will get C. And for this term, this will get cancelled and we will get AC. So it is AC plus B complement D complement is the expression. Now let us see question 3. So question 3 is, it is given that find the maximum clock frequency at which the counter in the figure below can be operated, assuming that the propagation delay through each flip-flop and each AND gate is 10 nanosecond. Okay, so we have a delay of 10 here, we have a delay of 10, a delay of 10 here, a delay of 10 here, a delay of 10 here, and a delay of 10 here. Assume that the setup time for the inputs of JK flip-flop is negligible. Okay. So how is the table for JK flip-flop? So the table for JK flip-flop goes something like this: 0 0 0 1 1 0 1 1. What is the expression? Here we have Qn plus 1 is equal to J Qn complement plus K complement Qn. So for 0 0, here we have Js 0. So this will get cancelled. K complement 0 complement is 1. So we will get here Qn. This term will get 0 as J0. This term will have 1 complement 0. So both will get 0. 1 into Qn complement and 0 into, so we will have 1 into Qn complement plus 0 complement is 1 into Qn. So we will have Qn plus Qn complement, which is 1. Then for the fourth term, we will have 1 and 1. So 1 complement 0 will get cancelled. We will get 1 into Qn complement. So here we can easily see that in the JK flip-flop, the output toggles when both J and K inputs are 1. So what we must do, we must ensure that for each clock, the output from the previous stage reaches the current state. Let me tell you what is this setup time. So what is setup time? Setup time is given here negligible, but it means that as soon as the data is stable, the next clock can be given. As what is the definition of setup time? Setup time is the minimum time before clock active edge, that data must be stable for it to be latched properly. And as this is negligible, which means as soon as the data is stable, the next clock can be given. Now let me tell you what should be the answer for this question. So here we know what is the propagation delay. What is the propagation delay? The propagation delay, as this is given that the propagation delay for each flip-flop is 10 nanosecond. Okay, so we get the time for the output from flip-flop once the clock is given is propagation delay is TPD. Okay, now let me rename this as flip-flop 1, this as flip-flop 2, and this as flip-flop 3. Now time for input to reach flip-flop 0. Okay, now time to reach the input to flip-flop 1. So what is the time in which input will reach over here? Here you can see there is no gate, so the time is 0 nanosecond. Time for flip-flop 1 is 0 nanosecond. What is the time for the input to reach flip-flop 2? It has to go through this AND gate. So the time is delay of this. It is 10 nanosecond due to one AND gate. Time for the input to reach flip-flop 3, it has to go through these two AND gates. So it is equals to 10 plus 10, which is 20 nanoseconds. So here, what is the minimum time? What is the minimum time for clock? It is equals to 10 nanosecond for this propagation delay plus max of all the gate delays, max of 0, 10 and 20. So time for clock is 10 plus 20, which is 30 nanoseconds. So frequency equals to 1 upon time. It is equals to 1 by 30 nanosecond, which is equals to 33.33 megahertz. So this is the frequency. So the answer is 33.33 megahertz. Here the answer is B complement D complement plus AC, and here the answer is 0, Qn minus 1, Qn minus 1 and 1.